Okay, so let me start here. So my name is Haroon Ahmed. I head up the solution engineering team, here, global solution engineering team here at Broadcom. Broadcom, just at a high level, is in the business of connecting everything, right? So when you think about the silicon that's in your phones to the hardware and the chips that are in your data centers, storage devices, software that's used to manage performance, build applications, and secure through Semantic, through the CA Technologies acquisition. So I came in through CA Technologies. So when I go and look at the current challenges that a lot of our customers are facing, and the speakers before me did a very good job of explaining the complexity of the network. The fact that majority of the customers that I go talk to today are dealing with multiple clouds, right? When they're building applications, they're moving out of their data centers, they're going into the clouds. They're using Azure, they're using AWS.
Sorry, Haroon.
Yep, sorry.
Were you actually showing your presenter notes? Can you swap over to your full screen? Sorry.
Okay. So let me just get going here. So once again, when we look at, like I said, the speakers did a great job before me. I want to just sort of talk about here that it's not only that the networks that are complex, because of the distributed deployments across multiple cloud vendors, data centers, mainframes are still there. They haven't gone anywhere. They will remain where they are. We have devices that are connected from, whether it's my mobile device or my web page or an IoT devices. There's a huge explosion of data that we're seeing. Everything is software defined now, right? Like the applications, yes, they are software defined, but when you look at the infrastructure, it's serverless. I can't even point to a server that's if I have a performance problem that it's slow, but the networks themselves and the velocity of change that's coming into these environments and making them dynamic is incredible, right? So when you look at the shift left movement and how, when you look at how development has been empowered to actually not only bring changes at a daunting speed into your environment, whether it's configuration changes, application code changes, new builds on new application builds going onto your iPhone. It's actually made the environments incredibly dynamic and incredibly ephemeral, if I can put it that way. So there's three major complexities that our customers talk about when I work with them. The first is they're dealing with a data explosion. So when it comes to solving a mission critical problem, there is too much data. They're inundated with data coming from all angles, from the system of engagement to the system of record and everything that happens in between. The modern architectures are incredibly complex. They're virtualized. If you look at an app today, an application, whether it's Java or Node.js, it's running on multiple layers of complexity, containers, virtualized environments, serverless architecture. So, and the third important thing that I want to sort of talk about here is the islands of point tools that are out there. So a lot of the customers that I talk to, are very much in a situation where they're dealing with tools from all vendors, right? So it's not uncommon for me to go see, if you look at the application monitoring world, for a vendor to be using tools from Broadcom, from AppDynamics, from New Relic, and even open source, right, to solve problems. So, and if I can just put it in a simple quote that one of my customers told me, it's like I have 14 watches and I still cannot tell the time when it comes to solving performance problems. So when I talk to my customers and you look at the complexity of the network and the application and the infrastructure, there's three key things that they ask me to help them solve. Number one is they say, look, customer experience is king. If my, for example, mobile application takes more than 3 seconds to load, or if a submit transaction takes more than 3 seconds to execute, it impacts my business, it impacts my brand, right? So help me monitor, at a business KPI level. A router being down, it's an interesting event, but it probably in the long run, it doesn't matter. If it's not impacting my business or my mission critical applications, I really don't want to focus on it right now. I want to deprioritize that. However, if that router or switch being down is impacting my business KPIs, at that point, please let me know and escalate it. So help me do that. The second thing is, once you tell me there's a problem, now I have too much noise. I have too many point tools inundating me with data. So help me filter through the noise, help me reduce the noise, and help me get to root cause faster, because that's the only way I'm going to reduce my MTTR. The third thing they asked me for, once you found the problem, And once you've told me that, this is how I fix the problem, this is the automation that I need to kick off, whether it's restarting a server or rolling back a release, help me build, help. I want the system to actually learn from the action that I've taken. And based on the learning, I wanted to recommend that action to me in the future. Because what that's going to help me do is going to help me do intelligent automation. So next time, instead of a user or a person hitting buttons or going through log files, the machine will do that for me, make an intelligent decision, and automatically take some self-remedial actions. However, when I talk to most of my customers, they're not there. When you look at, if I talk, when we discuss, the problems that they're having, they're telling me that 75% of the problems are still being identified by their users, right? So if my users identifying the problem and all these tools that I have in place are not, definitely have a big problem. The customers are still, struggling with too much noise, right? Which is increasing their MTTR. And what that means is that, some of the customers that I talk to said, on average, I have about 25 L1 folks. It's not uncommon for them to each handle about 500 alarms. And normally when I ask them, okay, so out of those 500 alarms, how many do they actually close with some action? They said about 50%. And what about the other 50% that get closed with no action? So it's the person that screams the loudest actually gets the most attention. And the third thing is, like I talked about, is the fact that there are just too many tools for them to deal with. And this contributes to the noise. It contributes to the higher MTTR, and helps and basically makes it very difficult for them when problems happen to keep a good user experience in place. Now, the cost of this is high, right? A lot of the times when you run into these situations, and I've been in war rooms many a times, been in the monitoring space for a long time, what we find is there's always the blame game. The app guy blames it on the network. The network says, I'm fine. They blame it on the infrastructure. And now when there is no infrastructure that you can go point to, it's all serverless. You're using Lambda architectures. How do you get to root cause? And a lot of the times what our customers are struggling with is not mean time to resolution. It is actually mean time to innocence, right? So you're trying to prove that it's not me so you can move on. So once again, the cost is high for our customers. It impacts revenue. It impacts customers. You can lose customers, damage your brand. But at the same time, the cost of actually finding problems, IT cost of finding problems, is not going down. It's going up. So let's get into the meat of the presentation. When I talk, if you look at this slide, this is the reality of probably your data of your NOC, right? For monitoring applications, you may have one or two vendors, probably even using open source. You have multiple vendors that are actually monitoring your infrastructure, both on premise and in the cloud. Same comes down to the network, whether it's monitoring flow, monitoring fault, monitoring performance, monitoring the software-defined networks. You probably have multiple vendors producing data. But in addition to islands of monitoring tools, customers are also struggling with islands of automation tools. You may be using tools like Atomic or Puppet or Chef, but you also have a lot of scripts out there, right, that are used for automation and remedial action. And last but not least, many other data sources that come in for change, for example, change events that are happening. If you went and made a configuration change on your network or your application profile, a lot of those events come in. All these events come into L1, and what it's really creating here is a signal-to-noise ratio problem, which we've all probably studied in computer science. This is a problem that humans cannot solve. You really need machines, and you really, really need smart algorithms in order to do this. So what do we need? How do we solve this problem? The first thing we need to do is we are getting metrics, we're getting logs, we're getting events, we're getting alarms, we're getting change events, we're getting all kinds of logs, log information, and all of that sort of being thrown onto the plate of the L1 resources. So we need some sort of, number one, algorithmic approach. And what that algorithmic approach needs to help us do is do three things. Number one, it needs to help us build some sort of situational awareness. What does that mean? I need to be able to draw a boundary around the CIs that are being impacted with all the data that's coming in. right? So what that boundary then allows me to do is build a situational group that I can actually focus on, right? And typically you'll do this across time. You'll probably do this across the text that comes in by applying natural language processing type techniques. The second thing that we need to be able to do is learn from history, right? If I don't learn from history, I probably will not be making the right decisions. So I need to be able to look at anomaly detection, look at outliers. Not only that, but I also need to be able to build causal graphs based on past behavior of how things went wrong, how alarms sort of came in and went wrong. And I need to actually enrich what I've already done around the situational awareness with that data. And last but not least, I need to be able to recommend actions, and I need to be able to learn and recommend actions for the future, and also have a feedback loop that comes back from my users, so that the next time I can say, well, this action I recommended, but the user didn't use it. The user used action B, that would actually work, and that should be the recommended action for the future. So 3 things: situational awareness, learn from history, and have some sort of recommendation engine. So what does that mean? There's 3 key things we need to focus on here. Number 1, we need to observe. So when we talk about observing, we need to be able to observe across the digital chain, which starts with the conversion rate on your shopping cart, on your application, or when you hit that transfer fund button for a banking application. I need to be able to observe all the applications, whether it's running on my mobile phone, the app could be running on my data center, could be Kix transaction on my mainframe. I need to be able to observe the infrastructure, right? The cloud, whether it's running in the cloud, whether the infrastructure is running on-premise in distributed or mainframe environments. I also need to be able to observe the network, right? And the network connects everything, right? And especially when you think about banking and trading applications, and you want to look at microburst behavior, which can actually impact the trade, I probably even want to monitor telemetry or flow data actually coming from my chipset, right? So this data that we collect, it's not just about the alarms, right? I need to collect more than the alarms. I need to be able to collect the business KPIs, the system performance metrics, alarms, change events, logs. But key thing here is the relationships. I cannot do root cause analysis. I cannot get to root cause if I don't understand the relationships and how things are connected. We'll put this into simple context of 4 T's, right? The 4 T's is, when I collect this information, I put it into some sort of data lake. Putting information into a data lake is easy. The hard part is the analytics, and analytics based on domain expertise that you apply to it with, to get to root cause. So number 1, I need to be able to analyze across time and text. Analyzing across time and text is great, but it's not enough, right? This will help me reduce noise, but it will not get me to root cause. So I'll give you an example of a customer that I talked to last summer around where they were using a tool that was analyzing and doing it across time and text only, and only for events, and only for alarms. What they said was, yeah, it did a great job of doing that, but it did not get me to root cause. And I asked them, what would help you get to root cause? And they said, I need the relationships. I need the topology information. So I need to know how a mobile click to submit a transfer fund connects to probably a server in my data center that processes it, right down to a Kix transaction, possibly on the mainframe, right, to the network routers and switches that actually process that information. That's what we talk about, relationships. And these typically can come through a CMDB, right, but they're not always accurate. Where we really want to get it is through deep monitoring on your networks, monitoring on your application. And last but not least, I need to be able to train the system, right? So once I recommend an action or recommend a root cause, I need to have a feedback loop. And that feedback loop should take in the concept of learning as well. Then once I've identified a problem and used the 4 T's to get to root cause, then I need to be able to engage. And engagement means opening a ticket. So this is integrating with your service test systems, ITSM type systems. I need to be able to have a bidirectional integration. So enrichment basically means I need to actually enrich the tickets themselves with better context around the problem. But not only that, when you talk about CMDBs, I probably also want to integrate with those. And those allow me to not only import service definitions that may be out there, but also enrich those service definitions based on the relationship that we've actually discovered in your environment for the application for the network, for the infrastructure, all those CIs and relationships, and feed them back and enrich your CMDB as well. And once we have the ticket open, we need to be able to look at taking some sort of remedial action, right? So initially that remedial action may be manual, right? Because I don't trust the system for self-remediation, but over time I want to be able to automate that. And I want the system to be able to recommend and system be able to take the action. This will help me not only reduce MTTR, but possibly if I use predictive analytics, right, capabilities, then it may be able to even eliminate MTTR because I'll fix the problems even before they happen based on predictions or predictions of future behavior. Okay, so there's a lot of tools. There's a lot of vendors out there that sort of work in this space. So the approach for this platform, this AIOps platform, has to be vendor agnostic, and we recognize this here at Broadcom. We've been in this space for about 30 years, right? If I think about network monitoring, application monitoring, infrastructure monitoring, we build the chips and expose the telemetry, as well as the flow information right down to the silicon. We also been in the the ITSM space, as well as we have tools like Atomic that are used for automation. We also recognize that when I go work with my customers, that they're not, they're going to be using solutions from all kinds of vendors. So the key thing about this platform is, number one, it has to be able to observe across metrics, text, relationships. It needs to be able to engage, and it also needs to be able to act based on that information. Okay, so just to summarize, there's 5 key use cases, right, that we talked about. It sort of summarizes everything we've talked about. Number one is I need to be able to monitor my business. I need to be able to monitor business KPIs. So I need to be able to do business service type analytics. I need to be able to tell you that, how's my transfer fund transaction performing? How's my, shopping cart submit conversion rate performing? I need to be able to apply some sort of algorithmic approach and not a rule-based approach to get to root cause. And for that, I need time, I need topology, I need text, and I need to be able to train the system. I need to be able to look at change also that's happening in the system, because whenever a problem happens, what's the first thing that gets asked is what changed? I also need to be able to look at the future and be able to predict what might happen, right? If I can see that a resource on a server like CPU or memory is going to be gone in reach 90% in 6 weeks, I need to be able to take that action early, take that action today, so I can actually prevent a future problem. And last but not least is, once I put all the business KPIs together, I get to root cause, I put change and predictions in context to that. I need to be able to remediate. I need to be able to eventually self-remediate. When I look at, this is a journey, right? AIOps is not a destination, and no one is there. Really, it's a journey. Most of the customers I talk to today are probably in the traditional monitoring space. The next step is probably looking at everything that I talked about around building a data lake, normalizing, having the right algorithms and approach to get to root cause. At that point, once you build your confidence on the root cause that you've received from the system, you'll probably start looking at self-healing type actions, self-remediation as the confidence builds up. And then predict, right? The last part of this journey would probably be, if I can predict the future, if I can predict what's going to happen based on all the historical behavior that I've seen, can I take actions early enough so that I can remediate them? And like I said, most of the customers that I talk to, I haven't met one that's necessarily very successful in the self-healing or predictive side, but majority of them are struggling right now with taking their traditional monitoring tools and saying, okay, if I throw this into a data lake, what can I do with it? The challenges that they normally end up facing is putting the data is easy, applying the algorithms and getting the right context is hard. And because it not only requires the data, but it also requires the domain expertise around that data on how to actually solve problems, how to apply them in a chain of events with the right context, collecting the right data across that chain to get to root cause. So I'll just finish off with a couple of examples. Some of the customers we're working with, it's a very large transatlantic bank. They're looking to increase their online interactions from about 83 million to 1.7 billion in 5 years. They know this is going to put a huge strain on their operational network, on their operations management. So they're looking at an AIOps type platform to actually help improve their operational efficiencies using noise reduction, using anomaly detection, using intelligent automation by about 30% to meet this demand. Another example is a telco, a very large telco that we work with that's going into 5G. What they're looking at doing is reducing cost. And reducing cost basically means is they want to reduce their L1 force by about 50%. They did a study of all their problems, and they found that 80% of the problems that they have can actually be done by machines, right? So they're looking at automating about 80% of the L1 tickets that come in using this approach, and this will help them, save hundreds of millions of dollars in savings.